You are on, sir. Thank you.
All right, cool. Hi guys. Let's see. I want to talk to you guys about the Modernizr Test Suite, if that's okay. It's pretty cool. So, Modernizr, feature detection library, detects if you have HTML5, CSS3 features, does so with JavaScript, and not UA sniffing, and it's cool. But you know, any JavaScript library reaches a point in its life in which it needs a test suite, and so at some point in the last year, I was like, Modernizr needs one, so I started writing one, and it turns out it's I don't know, I really like how it's written, and it's not a very typical test suite, so I wanted to kind of share how it's built. So the first thing I'll point out is over on the GitHub, if we scroll down to the bottom, there is a link to the test suite, which you can go and run for yourself. But we're going to run it locally. And so the first thing I'm going to do is, yeah, okay, cool. All right. All right, so I'm in my local Modernizr repo, and like most test suites, like most things, you might have noticed that Chrome doesn't really like file protocol, like XHRs don't work when you're opening up a local file, things like that. So it's very often that when you're doing local development, you need to start running a web server so that you can run something on localhost. So the first thing that I have a little alias in my shell, just server. I think this is somewhat common, but I just augmented it the other day, and it's even better than it was. So where are you? Server. Oh, yeah, okay, here it is. It's this right here, up at the top. Open localhost port 8000 and Python M simple HTTP server. This is really, so Python M simple HTTP server just runs a server within that directory on port 8000, and then this just opens it in a browser. It's like badass. So I just like hit that, and then I refresh, and then I immediately have a web server running in that folder, and it just opened up a tab too. Cool. So now I'm running up in localhost, and here is my test suite. So it might be pretty obvious that I'm using QUnit here, and all my tests are green. That's good. The tests itself are mostly boring. See, the tricky thing is with a feature detection library, the main thing that it's doing is detecting features. And so the big challenge there is that there's not a great way to verify that the results are correct. So the main aim of the library is to do something that only JavaScript itself can do, and the only verification has to come from another source. So most of it is, see, I make sure that let me zoom that. My globals are set up. Document.document element exists. The Node.js class that you might have placed on your HTML element is gone. The HTML5 shim or shiv, which is in Modernizr, has worked. So basically, we check to see that a like article element can be styled, and all sorts of other things. Basically, there's a pretty decent-sized API these days you can add extra tests. You can see if events are supported by certain elements, and testing things. So a lot of for building plugins that use Modernizr, there's a pretty decent API. So I test out a bunch of stuff regarding that. But within the test suite, I'm using some pretty cool tools behind the scenes, especially for some of the later things that I do. So the first thing that I want to show is, I'm going to go over here. Okay, cool. This is the source of, can I not zoom? I can't zoom. It's okay. Can you guys see this text right here? Yeah. Sort of, kind of. All right, so one of the things that I think is important for all JavaScript libraries is to make sure that you're not leaking extra variables into the global namespace. And it's kind of a tricky thing to do because it's really hard to know what all the variables that should exist on a window are. So I'm including here detectglobal.js. And detectglobal is a little small mini util that Kangax wrote. And so over here, this is what we're looking at. So essentially what Kangax does is he creates an iframe heading to about blank, and then he goes inside that iframe and just says, hey, what are the globals that are inside that iframe? And now compare that to my parent page. What are the globals that exist there? Figure out the difference, and then now we know what are the new globals that are in this namespace. So that's one of the things that I do, that I make sure that I don't have any variables that I didn't prefix with var and have escaped or anything else. And so I really like that. The next part is that I need to verify that the results that Modernizr is reporting are correct. And so what I do there is actually use data from caniuse.com. So if you haven't been to caniuse, then something's wrong. But caniuse is great. So like, while Modernizr tells you at the time what your browser supports, caniuse tells you for a bunch of different browsers and versions what is supported by each thing. And so this is maintained by a guy named Alexis Deveria, who now works for Adobe, and he does a fantastic job of collecting all this data and publishing it, and it's really fantastic. So one of the cool things that he did is he actually added a little API, and it has a JSON-P endpoint as well. So you can get all the data in here via JSON-P. So that's what I do. I'm going to open up, let's see, I'm going to open up the source on how I do this. Test, can I use? Oh, there we go, cool. Okay. I don't know how, is this going to work? Wow, cool. Awesome. All right. So in here, we're going to say that we're going to go grab the data from caniuse, and that's basically it. But then the big trick is that caniuse has all this data, and so it has its own data format. It comes in as this enormous JavaScript object. And Modernizr knows how it refers to video as just modernizr.video. Whereas the object that comes back from caniuse might be like HTML5 video. So there's a bit of like normalization where I got to make sure that I'm matching up with the data that's coming back there. So it's a little tricky there. So I have this little map to kind of translate between the two sources. But then it gets a little bit more interesting. One of the things that I'm doing is that because it's this enormous JavaScript object, it's kind of a pain to traverse. So I'm using a somewhat recent, came out like, I don't know, 4 months ago maybe. It's called JSON Select. And JSON Select is a little library that allows you to write essentially what looks like CSS selectors, but it's against a JavaScript object, a plain JavaScript object. So the object looks like this. Let's see if I can, yeah. The object looks like this, where we have like an author and then a drink preference, and then this inside that array is some things. And we can actually select, we can go through and traverse and pull out the value of whiskey with this sort of CSS selector kind of thing. anyways, it comes to be extremely handy when you have a big object, and I really like it a lot. And it works in IE6, which is pretty rad. So so we use that a little bit just to grab all the, let's see, all the browsers for each item, I think. I'm not sure. We'll do a few things. And now you'll see here, I have an index of, and this is probably operating on an array. And then over here we have object.keys. To do this, I'm using, so array.prototype.indexOf is not everywhere, definitely not in IE6. Object.keys is definitely not in IE6, and my test suite needs to run there. So I have a polyfills.js, and polyfills has, I think the most useful polyfills are just ECMAScript polyfills. So array prototype map, object.keys, and array prototype index of. Those three are so handy. I use these all the time. And so, you know, if you own the environment, if it's your page, like feel free to use these ECMAScript polyfills. So I'm using those here to save myself a little bit of headaches. And that's good. So I get that back, and then the next thing that I need to do is that, so I'm running inside of a browser here, right? So like QUnit is telling me that I'm running inside of Chrome 15, right? And Can I Use also has, you know, browsers and version numbers. And I need to match my data against this data. So the next tool that I use is UA Parser. And UA Parser was started by Lindsay Simon, who is the guy that made Browser Scope. And it is born from the user agent parser that Google uses internally. So because it's Google's user agent parser, it's pretty good. And so he wrote it in Python, and Toby Langell, who now works for Facebook, he ported it to JavaScript. And so he wrote it kind of as a node port, but I kind of adapted it for browser use. So now we can parse the UA of the current browser really well and know exactly what browser and version it is. I will also point out that there's really only two JavaScript libraries that I trust to do UA sniffing. Clearly, I need to do it here. UA Parser is one of them, and the other is GitHub Bestie.js. It's called Platform.js, and it's written by John David Dalton, and it's used on JSPerf. So those are the two. I might at some point just say that Platform.js is the only one to use. It looks like it's heading that way, because John's been really good about updating things. Add like Chrome 17 Plus support. What is that? Okay, well, I don't know. Anyways, so John does a really good job at updating this. So if you absolutely have to UA sniff, which you shouldn't, use Platform.js. Great. What was I going to say? Okay, so now we've parsed the UA, and now we can match it up against their data. And so what that essentially means in the end is that all this data comes in from Can I Use, and now we can basically say everything that Modernizr has reported up here, whether it has web workers, whether it has CSS animation, we're going to go through the data that Can I Use returned and make sure that the Can I Use result for each thing matches Modernizr's result for each thing. And hopefully this is all true. But there are some cases where it's not, and then you realize, like, you know, that you had actually disabled WebGL in your configuration, and therefore it doesn't work, even though normal configurations it should work. But it's a really good double check to make sure that there's no false positives, because there can be false positives in feature detection. The next cool thing is that behind Can I Use, Alexis uses a bunch of reference tests to make sure that to figure out if each thing supports each thing. And so down at the bottom of the page, I basically embedded in an iframe the page that Can I Use uses to see if there's support. And so there's a lot of lime, the color lime in here, but there's also some red. Whoa. I have no idea. Okay, I want to show one of these to you. So there's an auto test, right? So auto for like, basically in the case of, what does Modernizr say? And Modernizr says you support border radius. So we throw a green. Then there's a visual square. And the visual square for all of these has such cool code behind it. It's so rad. So I'm gonna, actually wrote this border radius one, so I'm gonna show it off. All right. Hello. Cool. All right. Cool. Okay. So here we are, we're on the visual ref test for border radius. And there's a few things going on. First, there's a parent div right here. It is 30 by 30, overflow hidden. Cool. Then there's a lime square. And then right after that is a red square. And the red square you can see has a position, absolute positioned at top 0. And so because this is top 0 and the parent is position relative, this should be over on top of it. And so what I'm actually going to do, is if I disable the border radius on this next one, it goes red. And the reason why is because I'm just going to bring this back for a second. And then I'm going to decrease the border radius. And you'll see what I'm doing is that this is this enormous, yeah, here it is. This enormous freaking square. And I have just changed the border radius so much that it's out of view, right? So when this red lays on top of the green, if border radius is working, you should only see the green, you shouldn't see the red, right? And so if there's not border radius support, then you see red in the target square. So like that's essentially how we're doing all these visual reference tests. So this is really cool because we have the JavaScript detected tests for all these things up at the top. This is just a dump up here of what Modernizr says. And then down at the bottom, we have a bunch of visual tests that actually test the legit features. So we get a really good idea. So this one page, you basically get a really good idea of the capabilities. The last thing that I wanted to show is that in the GitHub repo, so Modernizr, if you've been to modernizr.com and you go to production, and there's this builder, right? So like there is no modernizr.min.js. You cannot get the minified Modernizr. You have to customize it for your own use. So that's good because make sure that you only get what you need, and it's the smallest and fastest script that it can be. So you select a few things and you hit generate. So all these tests right here are essentially what's in Modernizr core. There's a lot of times that you want to detect things that are outside of what's captured on this page. And so in the repo is this feature detects library, feature detects folder. And here's where a bunch of extra stuff is. So like I want to know if CS3 box sizing is supported. And box sizing is supported in IE8 and everywhere else. So it's really useful once you don't support IE7 anymore, essentially. There's a bunch more stuff. And so these are kind of community contributed, and there's a lot, and we're hoping to grow this. Right now there's about 25, and we want it to be, you know, like 50, 70, basically anything you would ever want to detect that we can detect should be in here. There should be one canonical source for the feature detects, because if you write your own feature detect, there's a good chance you'll screw it up. It's the same problem with UA sniffing. The problem with UA sniffing is that everyone writes their own, and everyone screws up the first time that they do it, and the second time, and the third time. And we've screwed up a few times in Modernizr, but that just makes the test more robust, and we have documented a lot of the subtleties of the detection. So for each thing, there should be one detect, so we're trying to collect them all here. So we also want to collect all these, but because they're over in GitHub, I want to grab them, and so I actually do some pretty cool things to do that. What I wanted to do is in the test suite, this right here, this little section right here is where everything in that folder is shown. And what I actually do is I grab everything that's currently in the repo, and then I pull that in. And I'm going to show you this code because I think it's pretty rad. Where are you? Is it this? Yeah. Okay, cool. So I'm using a few things here. The first is I'm using the GitHub API through GitHub.js, which is a nice little mini library for dealing with the JavaScript GitHub API. Written by, what's his name? Brian Fitzpatrick? No. Anyways, I think he's in Seattle. He's really cool. Or he works for Mozilla? I don't know. He's great. And he wrote this nice little library. And so what it shows, what it looks like in here is, this is the code for it. GitHub, GH, object, repo name, or sorry, username, repo name. And then I say blob all, that's the method that I'm using. I want to get the master branch. And then that returns to me, basically, what are all the files in the entire repo, in the master branch. And then I just iterate over it. I find everything that's in the feature detects library. And then I basically want to grab the files. And this is my favorite part. So I get an array of all the file names. So I get an array of all these guys. And now I want to go grab those off of the server. So I do array, file names, map, and then that inside each I do a jQuery get script. So here I'm actually going to be using jQuery 1.7 because I'm going to use deferreds. So jQuery.getScript returns a JQXHR object, which has deferred abilities. So JQXHRs is an array of all these deferred objects. And then I can use this badass, right? So this is going to return an array of like 25 references to these scripts that I'm all getting asynchronously. And then I use jQuery when. And I'm going to use, because I'm using an array, I'm going to pass it in via an apply. The API is kind of funky, but jQuery when, apply, pass in all the XHRs, and when all of them are done, I call a function. And it's a function that I have right here called results to DOM. And so it was honestly, I haven't fucked around with deferreds much, but I did it for this. And the fact that I can say, I'm going to do all these things, it's all these asynchronous operations. I have no idea when it's going to finish, and I don't want to keep count of how many they are and like decrement a counter each time one finishes. I just do this, like these 2 lines, 3 lines of script, and then I know that when it's all done and ready, this function gets fired. That gets called, and then basically all that last bit does is just spit this out into the DOM. So I can now see the results visually and see that yes, indeed, I do have device orientation support, but I do not have emoji, unfortunately. You can feature detect emoji support, which is pretty rad. Make sure that you can see like a little toilet emoji or whatever. I'm sure that's useful. Okay, so anyways, I think that's about it. But that's the innards of how I created a test suite for feature detection, which is kind of funky. Yeah. Does anyone have any questions?
Questions? Is there a position fixed feature detection?
Good question.
I look for
yeah, so position fixed is a bitch, right? So it's detectable certainly on desktop, but that's not where you care. You care about it on mobile because mobile Safari, well, mobile WebKit is just a real asshole when it comes to position fixed. So a lot of people have sunk a lot of hours into finding one, and nobody did until someone did. So this happened. There it is. Yes. Okay. So this is it. So it's in Modernizr issue number 167. Is the only code on the internet to detect position fixed. There's currently code inside jQuery core to detect position fixed and jQuery mobile, and they both lie when it comes to mobile Safari. Was it this guy, Torbs? I'm not sure who to credit. But anyways, we have to kind of hold it in, make the test all clean and happy. But this is the test, and it reports correct results on all desktop browsers and all mobile WebKits. And it looks pretty heavy, but it works. So position fixed is now a solved problem, which is really, really good.
Cool. Anything else?
Yeah.